Welcome back to Daily Dose of Space. Today, we're not talking about a single object, a signal, or a discovery. Today, we're going on a journey, not across our solar system, not across our galaxy, but across the largest distance it is even possible to talk about, the edge of the observable universe. This is not a place you could ever reach, not with current technology, not with future technology, and maybe not at all. But we can still ask a powerful question. If you could travel outward, farther and farther from Earth, what would you actually see? What would the universe look like as you approach its ultimate boundary? And what happens when there is nowhere left to look? Leaving the cosmic neighborhood. Our journey begins somewhere familiar. Earth disappears first, shrinking into a pale blue dot lost in darkness. The sun becomes just another star, then a bright memory, and finally nothing at all. We leave the solar system behind and enter interstellar space, a region so empty that even the word vacuum feels generous. Atoms are separated by kilometers. Light travels freely, undisturbed, carrying stories billions of years old. Soon, the Milky Way fills the sky. From the outside, it is no longer a thin band of light, but a massive rotating disk of stars, gas, and dark matter. Hundreds of billions of stars bound together by gravity, moving in slow, graceful orbits around a supermassive black hole we can no longer see. And then, even that fades. The Milky Way becomes just one galaxy among many. The universe on these scales does not feel empty. It feels crowded. Galaxies appear in clusters, groups, and enormous filaments stretching across unimaginable distances. Gravity has shaped matter into a vast cosmic web with glowing nodes connected by invisible threads. At this stage of the journey, the universe still feels alive and structured. But this order does not last forever. Looking back in time. As we travel farther, something subtle but profound begins to happen. We are no longer just moving through space. We are moving backward in time. Light does not arrive instantly. Every photon has a history. The farther it travels, the older it is by the time it reaches us. When we look at distant galaxies, we are not seeing them as they are now, but as they were when the universe was younger. Billions of years younger. Galaxies begin to look different. They are smaller, messier, more chaotic. Star formation is violent and intense. Collisions are common. Shapes are irregular, as if the universe itself is still learning how to build galaxies properly. Colors change too. Distant galaxies appear redder, not because they are cold, but because space itself is stretching. As the universe expands, it stretches the wavelength of light traveling through it, shifting it toward the red end of the spectrum. This effect, known as redshift, becomes stronger and stronger the farther we look. Eventually, visible light disappears entirely. The universe must be observed in infrared and radio wavelengths because the oldest light has been stretched far beyond what human eyes could ever see. At this distance, we are witnessing the universe during its youth. And the closer we get to the edge, the younger it becomes. The last light. There comes a point where galaxies vanish, not because they are no longer there, but because they have not formed yet. We reach an era known as the Cosmic Dark Ages. This was a time before the first stars ignited, when the universe was filled with neutral hydrogen gas, drifting silently through expanding space. There were no galaxies, no planets, no heavy elements, and no light sources capable of piercing the darkness. The universe was simple, uniform, and almost completely dark. And then, at the very limit of what we can observe, something remarkable appears. A faint glow, coming from all directions at once. This is the cosmic microwave background. It is the oldest light in the universe, released roughly 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light was finally free to travel without being constantly scattered. This radiation fills all of space. It is not coming from a single location. It is the afterglow of creation itself. When we look at it, we are seeing the universe as it was near the beginning of time. This is the edge of the observable universe, not a wall, not a border, but a limit set by the speed of light and the age of the cosmos. Beyond this point, light has simply not had enough time to reach us. Yet the universe does not end here. What lies beyond the edge? This is where things become truly strange. The observable universe is not the entire universe. It is just the part we can see. Beyond it, space almost certainly continues. Galaxies still exist. Stars still form. Physics still operates exactly as it does here. But their light will never reach us. Not now. Not ever. Because space itself is expanding, and distant regions are receding faster than light can travel through that expanding space. This creates a cosmic horizon. Objects beyond it are not hidden by darkness or distance, but by time itself. Some theories suggest the universe could be vastly larger than what we observe. Others suggest it may be infinite. And some ideas propose that our observable universe is just one region among many, each with different physical properties. We have no way to confirm this. The edge of the observable universe is not just a physical limit. It is a boundary of knowledge. It marks the point where observation ends and inference begins. And perhaps the most unsettling thought is this: everything humanity has ever seen, measured, or experienced exists within this tiny bubble of visibility. The rest of reality may be unimaginably larger, richer, and stranger than anything we can access. The universe is not just bigger than we thought. It may be bigger than we can ever know. So when we talk about traveling to the edge of the observable universe, we are not chasing a destination. We are confronting a limit to sight, a limit to information, a limit to certainty. And the question is no longer what is out there. The real question is whether the universe allows itself to be fully understood at all. Because beyond that edge, the universe continues without us.